because really, like I explained the other day, this entire year is an exploration of functions that you've done already, like linears and quadratics, but also a boatload of functions that you've never seen before. So just going back to the basics, and I have a bunch of vocab up in the right corner. We have a domain and a range. Those should work hand in hand mentally for you. Something called a vertical line test, which hopefully you've talked about. Independent variables versus dependent variables, and then intercepts. So those are the vocab words that will come up. And I start in this first exercise just kind of with a word problem. An internet music service offers a plan whereby users pay a flat monthly fee of $5 and can then download songs for 10 cents each. So a variable is something that changes, okay? In this particular scenario, there are two things that may change. Number one, the number of songs you download. That can change. You can choose to download one song, or you could choose to download 11 songs. And as a result of that, what also changes? What will change as a result of downloading more songs? The cost, right. And so those two things that change kind of hand in hand with each other, one kind of being the cause of a change in the other, create your independent and dependent variables. The independent variable is typically what you manipulate, what you are in control of. You are first and foremost, chronologically, in charge of how many songs you choose to download. Then, as a result, the cost changes. So that would be the dependent variable. So, number of songs downloaded. I'll just put number of songs to save writing. And the dependent variable, therefore, is the cost, the monthly cost. The independent variable, like I said, that's typically what we manipulate. I'll call that the cause. And this would be the effect. Okay? The independent variable also is typically expressed using the variable x, and the dependent variable is y. I think that's Mrs. Rosanti's phone. So down here we have a couple different scenarios. The number of songs, like I said, that's our x coordinate. I mean, you can call it S for sure, S for songs, but typically if you think X, Y. So a couple scenarios, 0 songs downloaded, 5, 10, and 20, and trying to come up with a cost under each of those circumstances. So what would the cost be if we were going to download 0 songs? Angela? Not quite. Read that scenario. What's that? $5. Very good. So the reality of that is you can sign up for a monthly Netflix subscription and never once watch a thing, and you still have to pay your fee, correct? Angelin, is there something for short? Angie. Okay. Because I saw something shorter on your quiz, and how do you spell that? Okay. Cool. All right, so for 5 songs, we've got the $5 plus 10 cents for each of those 5 songs. So that's going to be additional 50 cents. So that'll be our $5.50. And then 10 songs, 10 cents each will be an additional $1 on top of that monthly fee, so $6. And then 20 songs is going to be an additional $2. 20 times 10 cents, $2 on top of the 5, so that'll be $7. So that's just a little table of values, some random inputs and outputs. Are we familiar with that? Inputs are your X's, are your independent variable. Outputs. We use a lot of vocab words surrounding this topic. And then a very common phrase is blank is a function of blank, which changes based on the word problem. In this particular case, you would say that the cost is a function of the number of songs. Really, because the cost is changing based on the number of songs. Whenever you see that phrasing, blank is a function of blank, whatever is the first word, it's like a kind of a nice cheater method of figuring out what's your x coordinate, what's your y coordinate. Whatever that first word or unit is, that's going to be your y coordinate, and it's going to be a function of x, meaning it's, changing based on x, essentially. So be on the lookout for that. So if I say that, I don't know, your grade is a function of the hours of sleep that you get, right? Your grade would be the y coordinate. That's the effect of your, hours of sleep. And that would be your independent variable. Because again, you control the number of hours you sleep. And then as a result, if you go chronologically with that, you maybe get better grades. All right, so writing an equation that models this scenario. So the cost in your y coordinate typically can, or a lot of times, not always, but a lot of times can be all by itself. So your cost equals, and it's computed by taking your $5 flat fee and adding on to that 10 cents per song. What would that look like? 10x. Any debate about that? Yes. 0.10, exactly. So given that this is $5, if you just leave that 10x, and you have to kind of know your units, like for this reason, if you just put 10x, you'd be $5 plus $10 per song, which is not what you want. So 10 cents versus $5 would be handled that way. Good. All right, so if we're going to create a graph of this, I hope you all recognize this as a linear equation, right? Y equals, here's your mx, your slope, okay, that's the rate of change per song, plus there's your y-intercept, your initiation sort of fee. So you should all recognize this as linear. Now, we are not going to start at 5 and go up 10 cents over one song, up 10 cents over one song for 40 songs. That would be asinine, right? So given that it's a line, you can absolutely just do 2 points. Your starting point, which would be at 0 songs and $5, and your last point, which would be at 40 songs, and we'll compute that in a minute. Actually, I'll go back up to my table. 40 songs, 10 cents each, will be an additional $4 on top of the 5, so that would be a $9 total. So this is going to give us a good, we already have our domain that they want us to graph along. There's your domain, your x values, what's happening from 0 songs to 40 songs. Your range is the span, essentially, of the y coordinates. So if we look, because I did go from 0 to 40, our range is just from $5 to $9. So I'll add that over here. Range is 5 is less than or equal to y is less than or equal to 9. And we have to talk about that because our y-axis is not scaled. So we really only need to go up to 9. That does not mean I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. Couple reasons why not. Number 1, you want to maximize the use of your graph. Number 2, you may want to realize and to really maximize your graph, we don't need to even include 0 through 4. Yes? We can essentially use a line break here and maybe have 5 start right there, do a little line break. Are you guys familiar with that? Kind of, you don't need $0 through $4, so why have it sort of thing. And then maybe I'll count every 4 lines as 1. So 1, 2, 3, 4, that could be 6. 1, 2, 3, 4, that could be 7. That could be 8. 1, 2, 3, 4, that could be 9. And then we have a starting point at 0, 5. And we have an ending point at 40 songs, $9. And you can essentially just connect those with a straight edge. Okay? We did take the time to do some points in between. I'm going to leave 550 out of this just because I don't want to deal with the decimal if I don't have to. 10 and 6, if you just want it a little more exact, 20 and 7. You've been scaling graphs and setting them up for a long time now, but it's an underratedly difficult thing for a lot of people because there are a lot of little decisions to make, and once you see it, you're like, oh, that makes sense, but synthesizing that on your own and coming up with how am I going to scale this and so forth. So connect that with a straight edge. And I am absolutely not going to put arrows on the end of this. This is a place on the regents that we often have to take off points. If you are given a specific domain over which to graph this, they don't want to see what happens prior to 0 for a couple reasons. Number one, that's impossible, right? You're not downloading negative song. And number two, on the other end, they didn't care what happened at 41 songs. They just wanted to see 0 to 40. So you really need to pay attention to that, because if you put arrows on the end of something that it doesn't belong, you're going to lose points, which is just kind of a bummer for us to have to take points off in June. And I'll do it all year long, obviously, so you're hopefully learning from that and making that mistake less and less. So when I label the x-axis, that's the one thing I am missing here. X is our number of songs, and there's no real unit with that in parentheses. On the y-axis is our cost, and that does have a unit. That would be dollars. So labeling and with units where necessary. Okie doke. So that's kind of manually graphing something. And then the next one asks us really to use our calculator to determine the range of this function here for these particular domain values. So a couple things. Number one, this is no longer linear. This is starts with a Q, ends with quadratic. Good job, Chris. All right, so that's a quadratic because, again, we talked at the very end yesterday, I have an x squared. Quadratic graphs look like what's the shape? A U parabola, right? P, parabola. So here are our domain values. Now, I'm not going to plug in, parabolas are different. I can't just do two endpoints and connect them, because that would make a line. That's not what that's supposed to look like. So we need more points than just the two endpoints. And I'm also not going to plug in negative 13 and negative 11 and negative 9 and plug in a bunch of different ones, because it's just going to take me a while. So we should all have our calculators on our desk. I think you probably are familiar with the table, but let's do this together. So first of all, go to y equals. If there's anything there, clear it out. And type in the function that we're supposed to be graphing, 2x squared minus 8. Is there anybody sitting here does not have a calculator right now? Because if that's the case and I find out in a few minutes, I'm not going to be very happy. And if you need one, you can just go grab one from up there. But it looks like we're good. Okay. And then as far as our table, we can go to our table there, but we're all probably going to be at a different looking table. Like mine is starting at 34 for God knows why, whatever function I typed in last time. So just to get familiar again, there's a table set feature, this blue one. So we would hit second window, and where do we want our table to start so that we don't have to scroll through a gazillion numbers? Negative 13. We want it to start at negative 13. And does anyone know what this little triangle symbol means in math? Change, very good. So how do you want your table to change? There are going to be times where we want our table to change like by 1/10 at a time. So it'll give you negative 13, negative 12.9, negative 12.8, and so on and so forth. This is not one of those. We want it to probably change by 1 since we're kind of counting through the integers. If I ever counted by 1/10, it would take me forever to scroll to see all of those. So why did I put 2? I meant 1. So we want our table to change by 1s. And now if I hit second graph, which will bring me to the table, I'll see a lot more. Okay? So the range is your y coordinates. So the one of the y coordinates is 330, and then it starts decreasing from there, and it's still decreasing, and I'm only looking up until 2. It's still decreasing, decreases to -6 to -8, and then it starts increasing again. It goes back to -6 and then back to 0. So definitely the highest value was at 330. I forgot. 330. What is the lowest value? Right. Don't make the mistake of pulling 0. That's not the smallest one. It actually dipped down to -8 and then started increasing again. So when you write your range in kind of this inequality format, you go your lowest number, -8, is less than or equal to your y values, which all have to be less than or equal to 330. And then graph this on your calculator. So we think graph is real easy, but just like with our manual graph here, we have to set the stage. We have to set the domain and range in the window appropriate to hit the numbers we're looking at. So just based on your domain and range, go to Window. Your X-min and X-max is going to follow your domain, so we'll make that -13 to 2 because that's all we want to see. The X scale being 1 is fine. That's just going to give you a hash mark at every 1 unit. And then your Y minimum, -8, to your Y maximum, 330. It's going to show you a very different picture than what I was looking at the first time. Now, I picked my X-mins and maxes, my Y-mins and Y-maxes to fit this bill exactly. You can always go a little bit lower and a little bit higher, a little bit lower and a little bit higher, just to get like a perfect, a better look at what happens. Like if I go -15 to 10, at least I'm encompassing this entire span. And then I can go -20 to 350, and it will show me something slightly different, but at least I see the whole structure of the graph. You see the parabola a little bit more clearly now. Okie doke? So really, again, an underrated skill, knowing how to set your window according to the problem at hand. You have to find your domain that you're dealing with and its corresponding range, and then you can set an appropriate window. Because how many times have you typed in a graph on your calculator, hit graph, and you literally see nothing, right? It's because you're not in an appropriate window. Okie doke? All right, flip to the back. Do you guys raise your hand if you've ever heard of the vertical line test? Very good. Okay. So in a function, every x value can only map to one y value. In other words, if you have an x coordinate of 3, you can't have two potential y coordinates that pair with that. Like if you look at relationship A, which I think we all can see fails the vertical line test, if I go to 1, 2, 3, an x coordinate of 3, there are two places. We have 3 and 1, 2, 3. We have 3, 4 as a point, and we have 3, -4 as a point. That's a big no-no for things to be a function. So that's where the kind of the vertical line visual test comes in, because if you draw a vertical line, which is in this case through x equals 3, if it ever hits twice, you've broken that rule. Your x coordinate of 3 is actually being mapped to multiple y values, which cannot happen. Okie doke? All right, Eric, open your eyes. Sit up straight. Give yourself one of these. We're good. Whereas in relationship B, every vertical line I ever draw will only hit that once. So which of the following is not a function? Relationship A is not. Fails the vertical line test. Intercepts, generally speaking, intercepts are a great feature to look at. This first, even though it's not a function, it still has two x-intercepts, 1, 2, 3, at 4. There's an x-intercept at 4 and also at negative 4. The y-intercept is the number at which it crosses the y-axis, which is at 6 and or negative 6. 2 y-intercepts is a big no-no, right? Because that would be a place where it would fail the vertical line test. This particular one has an x-intercept, oh gosh, where is that? Maybe at like 0.1. If I'm just estimating, it's definitely just slightly past 0. And this x-intercept over here, 3.8 maybe, let's say. We can have 2 x-intercepts. Nothing about those 2 points is filling a vertical line test. And we only have 1 y-intercept, which is good, at y equals 1. So you're all familiar with intercepts, yes? Any questions on that? Okay, and at the bottom, another quadratic, see, x squared, we have that parabola shape. State this function's y-intercept. What do you think that is, Owen? One. Very good. What are the coordinates of that point, Eric? 0, 1. And for the record, just so you know, the y-intercept always has an x-coordinate of 0. So a quick way, if you're not looking at a graph, if you're looking at an equation, if you want to find the y-intercept just from an equation, you just plug in an x of 0. 0 squared minus 4 times 0 plus 1 will give you 1. So to find a y-intercept, that's a big key. Set x equal to 0. Now we have 2 x-intercepts. They're asking between what 2 consecutive integers does the larger one lie? Well, here's the larger one, no doubt. So 0, 1, 2, 3, 4, it's between 3 and 4. Part C asks us to draw the horizontal line y equals negative 2. 1, 2. Which hits the graph twice. We're essentially going to solve a system here. So one equation is the parabola. The other equation is the flat horizontal line. Do you see in D where they pretty much set those equal to each other? If they both equal y, then they must equal each other. And the solutions to that is pretty much going to be wherever the x-coordinate is, where they're crossing. They're crossing at an x-coordinate of 1, and they're crossing again at an x-coordinate of 3. So that should all be a little bit of a review with how we solve systems visually. Okay? So your homework's coming around. Like I said, we'll go over this homework because it'll be obviously due tomorrow, and we'll go over the homework that was due today tomorrow as well. And